Okay, so this is a walkthrough of the third packet that I gave out. Start solving 3.3 percentiles. There's just measures of location. It tells you what percentage is left to the left or less than the data value that's in question. So it tells what percentage is to the left of or less than the data value in question. So, example of that, if your baby's head is in the 90th percentile of the babies in the United States, that means that if we were to measure all of the babies in the United States, then 90% of them would have a head smaller than your baby's head. And also that means that 10% would have a head that's larger than your baby's head. So the way you represent that is P sub 90 or P90. That just represents 90th percentile. The way we would find a percentile, you find the number of values that are less than the value you're talking about, less than X, and replace that over the total number of data values that you have and multiply it times 100. So find a percentile for a cookie with 23 chocolate chips. So first you have to put them in order. So I already did that with this data set. You have all of these cookies. Each one number represents a cookie, and each number represents how many chocolate chips is in that cookie. So in this cookie, there are 30 chocolate chips. In this cookie, there are 25 chocolate chips. So you want to know the percentile for a cookie that has 23 chocolate chips. So first, you count how many data values you have. 1, 2. So we have 40 cookies all together. And then you want all of the numbers that are less than the 23. So you look at just this top row, and that should be 10. So place that 10 over the 40, and then multiply by 100. So the percentile of the cookie that has 23 chocolate chips, 25th percentile. Quartiles, the measures of location that separate the data into fourths, into 25%. So into fourths. So the way it'll be broken up, you have your smallest value, minimum, your maximum, and then in between you have quartile 1, quartile 2, and quartile 3. And once again, they will split up your data into 25%, into fourths. So the way we'll find our quartiles, first you're going to list your data values from least to greatest. A lot of people forget that first step. Make sure you do not forget the first step. We're going to list your data values from least to greatest. Quartile 2, the one we'll find first, that's the median of the whole data set. That's going to split your data in half. Then you can find quartile 1, that's going to be the median of the first half of data. Quartile 3 will be the median of the second half of data. So if you notice, all three of them are just medians. So you find the median of the whole data set, the middle value of the whole data set. Then you find the middle value of your first half of data. Then find the median or the middle value of the second half of data. Also, this section may ask you for the 5-number summary. And it is just those 5 values I just mentioned. Minimum, Q1, Q2, Q3, and your maximum. Your box plot, or box and whisker plot, is going to be a graph that consists of a box that has lines that extend from it that goes to the minimum and maximum. Those are called whiskers. And once again, it's centered around those 5 values: your minimum, your maximum, Q1, Q2, and Q3. A modified box plot is when your whiskers extend to the minimum and maximum values that are not outliers. So if we want to have an outlier represented, it will be represented by an asterisk. Now you can't have more than one outlier, so that means you can't have more than one asterisk that's sit out there. But the whiskers will extend to the values that are not outliers, the minimum and maximum values that are not outliers. The way we will find our outliers is first we're going to find the interquartile range. So the interquartile range would be the middle 50% of your data. Your IQR is the middle 50% of your data. And we'll find that by taking Q3 and subtracting Q1 from it. Then we will be able to use that to establish our boundaries. Your right boundary will be Q3 plus 1.5 times your IQR. Your left boundary will be Q1 minus 1.5 to IQR. So these boundaries will be numbers that we will use to establish what our outliers are. Remember, your outliers are extreme values in comparison to your data set. Very, very large or very, very small values that are in comparison to your data set. If something is greater, if a data value is greater than your right boundary, then it's considered an outlier. If it's less than your left boundary, then it's considered an outlier. Those are our boundaries. If anything exceeds those boundaries, those are our outliers. And that's what it states here. If data value is less than the left boundary or greater than the right boundary, it's an outlier. So let's look at this data set, construct the box plot, and give the 5-number summary. So yeah, I did a little scribbling here. The data values are 7,224, 8,709, 8,784, 10,060, 10,089, 10,125, 11,445, 11,476, 11,844. So those are your data values in order. So remember, the first step is to write the data values from least to greatest. I've already done that. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. So when it comes to finding our median, we don't have a middle value since we have 10 data values. So what we're going to do is take our 2 middle values, 10,060, 10,089, add them together, divide by 2. So 10,074.5 would be your Q2. That's going to split your data in half. So now my data is split into half. I have 5 data values on top, 5 data values on bottom or in the second half of my data. Since I have 5 data values, that means I have an actual middle value, which is 8709. Then out of the 5 data values down bottom, I have a middle value, which is 11,445. So that's Q1 and Q3. Now I can find my IQR. It's Q3 minus Q1. And that gives me 2736. And going back to Q2, Q1, Q3, don't forget all they are medians. We're just finding middle values. Don't forget that process. Step 6, we're going to establish our boundaries. Remember, that's right boundaries Q3 plus 1.5 times the IQR. Plug that in, that gives us 15,549. Left boundary Q1 minus 1.5 times the IQR. Plug in those values, 4605. So if anything is greater, if any one of my data values are greater than the 15,549, then that's an outlier. If anything is less than the 4605, once again, that's an outlier. So my 5-number summary, my smallest value is 1, 8709 is Q1, 10,074.5 is Q2, 11,445 is Q3, and the max value is 11,844. Now, are there any outliers? The answer is yes. When you go back, as far as 15,549, we don't have any values that are greater than that, but we do have one value that's less than the 4605, and that's the 1. And so we'll represent that 1 as an asterisk, and all your other values would be as such. That means the whisker would extend to the lowest value that's not 1, which is 7229. Okay, or was it 7224? Okay, so let me know if you have any questions on the process.